I will try to show it in detail later. There is something about guiding principles for gasketing and best practices. So, I will try to show the picture a little closer. You will see the hope you have read it ahead of me, but then what may appear to be a simple and easy to install component actually requires knowledge and understanding of its working principles and characteristics. So, in the case of electrical, only two things happen. One of them is external fluids or dust may get inside, or in the case of our CNC equipment, we have the issue of metallic chips, and sometimes the coolant that is used while cutting can also carry the chips and then damaging the machinery inside, and alternatively things inside coming being spewed out and operators getting stuck about it. Read it for yourself, it will make slightly better understanding. A gasket is any deformable material that is used to create a static seal and maintain that seal under the various conditions of a mechanical assembly. While a seal is created by compressing the gasket material, causing it to deform and flow into the imperfections of the sealing surfaces. So, if you see our automobiles and several places, in principle metal to metal continues to the best. Anything else you join inside is a compromise up to a level. If I go back, this seems to be the crux of the problem. We have a bolt load, then hydrostatic end force try to push the flanges apart. While it looks not so important as to why we need to follow it at all, it is very important that you should see the basics. 2 or 3 things you notice is there are clamping forces involved, and every time you remove a gasket and start, you need to reapply the force. If you see that street light boxes, when it first came, I am sure it worked perfectly all right. Nobody will compromise other human safety and all that, but eventually when things started failing and people have to work under very unfavorable conditions, maybe it is in the middle of the night, it is raining, quickly they have to restore power, and probably it is somebody else's duty, not the people who are in the regular maintenance people, they are the emergency services. So, you notice that this very basic thing about clamping force, the bolt load is not thought of much. Then you see other thing, chemically resist the fluid being sealed. In our case, it is a little bit of water and maybe oil, withstand system temperatures and pressures without serious impairment. How can there be pressures in an ordinary box, ordinary enclosure? The simplest is when things get hot inside, pressure builds up. Similarly, when outside temperature is high, or in the case of aircraft and other things where quick change in altitude is there, pressure keeps changing, outside pressure falls off. So, if you are one of us people who carry canned or bottled pickles, you would have seen that whatever best action you have taken, no, probably it would have leaked. So, the best what do you call, old practice of putting everything in a tin can does not really help. Somebody takes a lot of interest on making sure that these things when exported, how liquids are done. So, we will if you see here, gasket is supposed to resist creep and crushing, must not contaminate the fluid, will not promote corrosion, be easily removed, which probably happens under all conditions. One of the first thing is gasket creep is real. You cannot take two surfaces and jam some elastomer material directly in between them. If you jam them, chances are it will get permanently corroded. Two examples are given here: tangential flange surface interface leakage, another is permeation through the gasket body and leakage. This is taken from the Fluid Society, where they are very much interested such that no leakage can happen at all under tremendous pressures also. Probably it belongs to the chemical industry, but still the reality is all this stuff. Why gaskets fail? I intentionally made it a little bigger so that you can see it. Not sufficient torque is applied. So, if we go back to the street light box outside, in the previous picture what I have shown you, one of the things you will notice is that a small clip given on the side is not sufficient for it to really isolate the external atmosphere to the internal atmosphere. I will see if I can locate it here. See what they are just simple small clips which are mounted outside. I do not think they are sufficient to exert enough force to make sure that it stays bolted. So, what started as a genuine interest in making this real, still it suffers from the problem of gasket not having enough clamping force to make itself there. You see, this side there is no problem, there is enough leverage, but it leads to the other problem, saying more force than required has been put, and then over time and over the ambient temperature, parts of the gasket have cracked here. The crack may or may not be dangerous, because much earlier to that probably the electrical failure has occurred, but still it is real. I will call it now saying it is for real. You have seen that last thing in that gaskets do not fail, the joints do. Uncontrolled installation practice. I will modify it a little in our case, saying in our case it is uncontrolled repair. During installation there is no problem, and eventually during practice, during repair it fails, and then you have seen this poor flange design and weak materials. So, all the lipping and all provided may or may not In this case, they have made this meant for probably hydraulic and other joints, but in our case it is equally valid for our enclosures design. You see here, one of the first thing is surface flatness. So, if there are already tool marks and dents created, small imperfections, things are likely to fail, because the gasket was not designed for it. You understood, no? Any small imperfection, what starts as a plain flat surface may just have one small dent in it. Good example you will notice is probably if your automobile, if your car has got into a crash and you cannot remove the dents and all easily from the bonnet or the boot edges. Start for the first failure, the bonnet does not close anymore. Normally there is no problem, because from the visual point of view you will probably adjust it, but then when you drive in a rain, the water channels get blocked. So, I do not think you make a very regular practice of looking for how driving rain water gets emptied from the rooftop of your car, but still it is real. For smallest dent we have a little issue, and then if you live in the tropics like what we do, usually you have a windscreen or windshield which is also fitted with a gasket. Newer ones are all, they use an engineering adhesive to practically stick the glass to the sheet metal. Even there, after repeated use of temperature high and low, eventually things crack and a little sort of a leak starts forming. So, I will just, I will see if I can this is general. So, you can use it as an abstraction. You need not worry too much about the helmet and safety goggles, but you need to make sure that you use the correct amount of forces and correct way of installing things. And you see here a wire brush for cleaning the surface of any materials which I have gotten, and most important is a small lubricant. You have a gasket grease that is usually applied and you need to reapply it. This I think is sufficient for us from this. At this point I will now try to move on to towards the end, where many practices and various types of materials are used and so on. I think we need not worry too much about it in our context, except to say that yes, gaskets are real. You see all this beautiful IP68 enclosures, they almost look a little like industrial equipment. I hope you agree with me, because they are industrial equipment. So, you have all this fantastic flanges here, and then if you remember, you are talking about the bolt load and how to install things and all that, all of it comes here. And a street light is not a very, I will say not a very dangerous thing, but imagine if you were to be there in a industry, this becomes really risky. Same thing, but in this case it is a control panel. I am not able to access the image. I am not able to enlarge it. Tried as much as best I can do. Seen that? It looks a little like your IC engine crankcase or the top covers which has been bolted down. So here it is very critical. It may be a flame proof enclosure. It may be used for other designations. Now if I go back, things are pretty big and hard. All the things which I have been describing to you in the earlier catalog of gasketing and safety will come all the more important in the case of flame proof enclosures. Fortunately for us, always a fail safe mechanism is there. Even the studio has some sprinklers and all that, which do not need electronics. We just have a small capsule which bursts and the whole thing gets flooded. Looks nice, isn't it? The sad thing is, I do not know how to get out of this place. So they have put a big thing saying push. Hopefully nobody is ever left here alone. There are some minimum of 3 people monitoring me. I am safe. But in the case of industry, if you go here to this thing, you see here, it seems very simple, no, to just start a pump and all that. Do you have to do such a lot of this thing? Yes, it is real. If the slightest spark is induced here, it can go and trigger anything outside, not just for solvents. Even in the case of solids, I have given you an example of dry mill powder. That itself acts like a combustible material. You see here, extreme additional precaution has been taken even for the on-off switches, to make sure that accidentally you do not switch on something, similarly accidentally you do not switch off something. And then a lot of tubes like thing and all, I do not know, maybe it goes into some other enclosure. I have no clue what it is, but what I can say is by looking closely at it, the very fact that there is a close welding, it looks like it is some mechanized welding. Obviously it is a very important equipment. Only I can think of is you find these things in high vacuum which we have in our semiconductors facility downstairs, but gasketing and electrical is real in all these things. There is nothing you can ignore about it. Good. See, things are getting very interesting about it. So we can keep looking at all these things. You have seen this here. While an electrical enclosure looked very convenient and easy for you, you have a look at even this stuff like motors. So, normal course we do not expect a motor to cause much of damage, is it not? So, both ways, neither should the motor get damaged, nor that should the motor damage things outside. In general, you have all the necessary practices here. Further, you see here the terminal box, the way the terminal box has been sealed. You cannot just take loose wires and then force them into the terminal box. It has to have completely concealed conduits, which themselves have some special features that are built into it. So, I can go on like this. Now, when you are to select, you see this beautiful a proper way to do things. This is probably what was needed in that conditions which I have shown you on the street lights, but this is expensive. Probably it costs overall maybe 4 times as expensive as the cheaper ABS enclosures and all which they have put outside. But you see that failure to failure to failure, it leads a little like the way lot of software companies make a living. Patch on patch, buggy code. You start with the buggy code, add a patch, add a patch, add a patch, and then until the next build comes, you can keep on adding patches. That's where probably we create jobs and lose them. So, you see here, practices like this ensure that you will never have a field failure. Understand? No, even everything inside is made properly, made, installed, sits properly the first time. So, it is unlikely that you need to redo things. No more patch up is required. If you end up with a patch up, you have a problem. Instead, I know it is stupid and maybe out of context, excuse me for saying we know about the regular various types of operating systems versus the operating system which has less failure, less chance of getting attacked because it is closed. And then otherwise extremely open, we have the Linux. Linux survives, iOS survives, and in between we have so many things, people trying to attack us one way or the other. Seen this beautiful, really examples of the IP67 enclosures. So, maybe I should take you here. So, it looks like our computers and internet you have seen this IP67. We thought we may not need these things in our normal switches and so on, but you see here it is there. Other than closing it, you notice something else also at the bottom here. You have seen it? There are two beautiful connectors, because a lot of times this is left in the open. So, we have the IP67 enclosure, and the bottom you see here, anything you can think of, shock and vibration, usual dust proof, anything, and then one more thing here is something new has been added here called lightning immunity. oh, I do not know how it is achieved, but it is. Otherwise, you do not have your communication equipment working in the case of a storm. These all look reasonably simple, but you will notice that a lot of data, oh, I am sorry where I have ended up with. Oh, yeah. Oh, I think he will skip, yes. I was looking for this. A simple terminal box. A terminal box should not need such a lot of analysis as I am trying to do, but the beauty is, unless you have this gland nuts, unless you have all this other hardware, chances are it will fail. And now maybe I should I think I will stop here. Thank you. I will continue the next time, because two things, you will get saturated by this repetition, and then an important thing about actually how they implement EMC, EMI gasketing in enclosures. A big lecture is there, and then before I go out, I thought no, I will continue to show you that the military has been using this for a very, very, very long time. You have seen that from 4 onwards, no, sealing of equipment, dust proofing. As you go down, number 9, 8 and 9, mechanical ruggedness to withstand shocks, bumps and vibration, design of shock mounts, and so on are all there. These will be scanned and put up so that eventually you can read them, but I thought it is a good place to start. So, I think thank you for this session. We will meet again next time with little more detail. It was a lot of detail. The issue was only about how to make an equipment dust tight and also seal it, and then talk about installation and talk about repair, and after repair how to get back to the original thing. So, thank you.